So my presentation is building community trust with proof of reserves. I am representing TxQuick and BlockPal today. BlockPal has recently acquired TxQuick, or is in the process of acquiring TxQuick. So a little bit about me. I started back in the mid 90s in tech by starting a hosting company as I was a sophomore in electrical engineering at Oregon State University. Did that for decades, literally decades. Ended up transitioning into doing online gaming. Worked with Caesars Interactive and Playtika on a couple projects. One of the projects in particular, when I left, was at 2.5 million daily players, and another project, which was the rewards program for Caesars Interactive, was hitting north of 20 million daily users. So I've done some good sized projects. While I was there, I picked up an interest in cryptocurrency, just an evening and weekends sort of thing. Put together a Litecoin mining pool, put together a Bitcoin and Litecoin exchange. Name of the exchange was BTC Trading Corp. Kind of took off on me and was taking up quite a bit of time, and eventually even picked up a bit of regulatory interest. You can Google my name, and you'll find that the SEC ended up not being too happy with me for a little while. So we ended up having to shutter the exchange, but that exchange in particular on some days was doing more volume than Mt. Gox. And when we shut it down, probably one of the only exchanges to ever shut down that had everyone's cryptos around. And that's on the basis of all those years of web hosting and understanding web application security and whatever else. So now I've kind of picked up the exchange code again and started developing it again. And we're going to launch our exchange here, hopefully not too long. Working our way through regulatory stuff right now. So we've probably all been hit pretty hard once or twice, especially if you're an early adopter. You've been hit pretty hard with a loss, a crypto loss. Me personally, it's been a minimum of 3 times, probably more, but the ones that stick in my brain are Mt. Gox, BTCE, and of course, if you're Canadian, Quadriga. And I've been affected by all 3 of those. Every single one of them has been painful. So I've kind of developed a passion on the basis of having operated an exchange, on the basis of having used other exchanges, a bit of a passion for transparency in an exchange, and being able to kind of build trust with your customer that can extend long term. I firmly believe that an exchange that can operate, with customers that can trust it, is going to be an exchange that's around in 10 years, 25 years, 50 years, whatever. So what's the big red flag? What's the big issue here? Exchanges that operate as fractional reserves. If you have an exchange operating as a fractional reserve with an asset that is appreciating in value, it kind of creates this sort of iceberg of pain. You only see a little bit on the surface, a few complaints here and there about not being able to withdraw every once in a while, and then all of a sudden there's this the bottom of the iceberg just appears out of nowhere, and everyone's suffering, and it's horrible. Whereas if that exchange had just disclosed that it was a fractional reserve when they were compromised, maybe it was even 4 or 5 years ago, would have given existing customers a chance to recover, and it would have prevented new customers from coming in and kind of contributing to their pool of customers and the pool of pain, so to speak. So proof of reserves, the idea behind proof of reserves is giving the customer the ability to prove that what they have and what they're operating with is that they're not a fractional reserve, and giving that customer the ability to prove that without having to trust just your word, having external tools. We already know the blockchain helps you prove custody. but having the tools to also prove the liability side of things. So essentially, whether you're fractional reserve or not is when your reserves are lower than your liabilities. If your liabilities exceed your reserves, then you're fractional. And the gist of that is that a proof of reserve is kind of a misnomer. It's not only the reserves that matter. What matters is proof of solvency. So you also need proof of liabilities, and I'll get to that here in a little bit. Another aspect that's really important here is I've seen platforms that have done proof of reserves, and they might do it once a year. They might do it once every few years. They might have done it once and then given up on it, decided it was too hard, decided it was too much trouble, too much effort, whatever. Similar to compliance audits, other financial services compliance audits, there's a type 1 and type 2 for SOC audits. The type 1 is a point in time, and the type 2 is an ongoing sort of effort is being made on an ongoing basis, and regular audits are being made, and those ongoing audits are important. The fact that the process is ongoing and there's continued cooperation and consistency and participation in that process is really important, because having a proof of reserves audit that was done 3 or 4 years ago is almost worthless, because anything could happen between now and then. So TxQuick, as I mentioned before, proving solvency is reserves have to be greater than the liabilities. So the reserves part is pretty straightforward with blockchain. Blockchain makes it super easy. You publish your address, and people can look it up on a block explorer. What's sitting at that address? There's block explorers for most of the non-privacy coins, so you can go up and look up on Ethereum how much ETH a particular address has, or how much Tether a particular address has. Similarly, on the Bitcoin, Litecoin, Purecoin, all of those blockchains, you can go onto a block explorer. If you have an address in hand, you can figure out how many coins are sitting on that particular address. So TxQuick implemented a wallet status page. The wallet status page lines out, and this is a screenshot from a sandbox. So you can see in our sandbox, we've got sort of fake currencies floating around and fake addresses floating around. But as an example here, we've got a hot wallet that is a Bitcoin testnet hot wallet, and you can see the address, you can see the balance on it, and then you can go on a testnet explorer and you can confirm this is the address, this is the balance. So that's proving the reserves. That's the easy part. So what's the hard part? The hard part is proving your liabilities. So typically, the liabilities are the contents of your database. It's the contents of all of your users' balances in your database. So how do you share your database content in a way that everyone can participate, and you're not giving away private customer information, and you're not compromising anyone's security anywhere in the process. So what TxQuick has done is we developed a third-party Merkle tree proof verification application. It's written in JavaScript. You can host it. It even works offline. It just runs in your browser, sort of thing. We put that on GitHub, so anyone can go here and you can peruse our code. Anyone can download it. Anyone can host it on their website. And this is one of the key features of this particular solution. Anyone can host on their website, so that means that for the proof, participating in the proof, you're not trusting us. You're not trusting us to be running this JavaScript code. So that at the end, when you see the result of the run of the JavaScript code, and it gives you a green light, it says you were included in the proof liabilities, you know that you can trust the code because it's hosted by a third party that you trust. So you have to get third parties to participate. TxQuick in particular has been working closely with the Quadriga Initiative. It's a Calgary-based organization, a bunch of people that got burned and are Bitcoin and blockchain technologists, and figured that they could help contribute to it not ever happening again. Great group of guys, meet up with them on a regular basis. And then the other part of setting this up is as you onboard customers, you have to have sort of reasonable defaults, And you'll see a little bit more why this is important, but you have to set reasonable defaults so that you're not requiring them to participate early on before they even understand what the process is, but you're still allowing them to join in later. And you encourage them to customize their settings. And the customization, the more they customize their settings, the more valuable the proof is later on. And then, as I mentioned earlier, making this an ongoing process. So you're doing your audit at monthly intervals. We thought about doing it more frequently. More frequently, unfortunately, you don't end up with quite the participation. We figure that monthly is probably about the interval that you could get regular participation. So the flow is generating a customizable proof sentence for every user. So proof sentence, I'll show you in a moment what it looks like, but every user has a proof sentence, and it's unique to every user. You hash all those proof sentences together using SHA-256, and you include the balances, and you put those into a Merkle tree file. Merkle tree file helps prove the integrity of your overall database that you're releasing. So a Merkle tree file can be looked at as a sort of database in a lot of ways that you're distributing publicly. So then the next step is to publicly distribute your Merkle tree file. And the way that we do that is we publish it to the GitHub project within a subdirectory, and we've got a naming convention that lets you identify each audit by the time and date that those audits were performed. So then you want to go out and you want to encourage users to participate. The more people participate in your proof of liabilities via your proof sentences in this Merkle tree file, the more valuable and the more valid the audit is. And that's because what you're trying to prove here is you're trying to prove that the sum of the liabilities that you're telling people that your total liability is accurate. And so if you were trying to game the system, you would selectively leave out a customer here, a customer there, maybe somebody with a big balance that you don't think is likely to try and run a proof sentence or try and participate. So you leave out a few customers here and there, and now your liabilities look lower than they actually are. So the more users participate, the more likely such a scheme is to get caught. And I mean, ideally, you would have 100% participation. That's not going to happen. But the more people participate, the more likely someone trying to game the system would get caught. So the more people participate, the more valuable the audit. Whoops, I went the wrong direction. So this is the interface. This is the actual interface from TxQuick profile. And what we're trying to demonstrate here is how easy it is to participate and configure custom user proof sentence. So first thing, user decides whether to include their balances or not. It's a simple checkbox. The reason that this is important is because if a user doesn't include their balances in their proof sentence, then their proof sentence wouldn't necessarily have to change over time. They might be able to participate in automated fashion. So if a user wanted to write a script and just participate automatically on a monthly basis, then they can uncheck this box and they can automate however they want participate in checking their proof sentence. So that was an important feature to add. The Quadriga Initiative came up with that idea. People will be able to automate participation, thus we'll hit higher participation overall. Next thing you try and configure that you configure here is how much we either obfuscate your email, and we do that by default. Your email is obfuscated. You have the option to include your full email, or you have the option to include a custom phrase. And the idea here is that this is something that represents you. This is personal to you, and it ends up being sort of a global, unique identifier. And this is important because you avoid collisions in your Merkle tree, and by having a unique phrase here, so that and this helps contribute to the validity of the audit, because if two users had the same email, or if two users had the same custom phrase, then there would be the potential ability for an exchange to just represent that user once in the audit, rather than having to represent all of the users individually. And then what you put in here, remember that you're plugging this sentence in on a third-party website. So that's why we obfuscate the email by default. We don't want to give away users' emails. But full email is an option if that makes you more comfortable. Or again, I think that the custom phrase is probably the best way to both protect your privacy and also be able to participate in a way that avoids those collisions. Users able to set anything you want as personal identifier. You can make a whole sentence, doesn't matter. You can also see on this page a sample of what your proof sentence will look like. This is important, kind of setting expectations. And you can see a sample of what a SHA-256 hash looks like. And this is important because a lot of these people that are participating are not going to understand cryptography or SHA-256 hashes or anything like that. They're going to be all kinds of confused. So trying to make this process as easy and as straightforward as possible is really important. So that's the proof sentences. When TxQuick generates the Merkle tree file, we take the proof sentence for every single user, and we hash it into using SHA-256. We hash that, and then we add to the file. And there's an example of a file right here in the background, the format of the file. We add to that the actual balances, and this is important because the hashes are one way. You can't take a hash and go backwards with it and kind of extract it. So we also include the balances in the CSV file as represented for everyone. And this means that a user can take this file and calculate out the totals that are represented in the file. And of course, reference that their hash, like if they wanted to open the CSV and investigate, go really deep, they could compare the balances that they've plugged in from their proof sentence to the balances that are included in this CSV file. But this is how the Merkle tree is generated. The platform generates this file automatically. It's a regular automated process, and then it's a manual process to upload it to Git. User participation. We've tried to make this as simple as possible, as straightforward as possible, because we want maximum user participation. The process is first you log into your TxQuick account and you browse to your profile. In your profile, there's a proof of reserves tab, and in that proof of reserves tab, there's a section showing all of your available proofs. And these are audits that have happened while your account was open. So if you're 5 years in, you could go back and participate in proof that was 5 years ago. If your account's only been open 6 months, you could go back and participate in proofs back to 6 months. But the most recent proof will always be right at the top. You copy your proof sentence, and there's a little button there that lets you copy to your clipboard. So you copy your proof sentence, and you browse to one of the third-party proof of reserves websites. One of the partners, the Quadriga Initiative, is one of those partners that will likely be hosting the proof of reserves JavaScript code. You paste your sentence in, and you click load audit file. What it does when you do that is it processes the sentence. One of the things in the sentence is the audit date. So it extracts the audit date from the sentence. It goes to Git and downloads the most recent audit or the matching audit file for that date. So it all happens in the background, grabs the Merkle tree audit file. Then you have a button that you can click that's run verification. So you click the run verification. What it does is it extracts all of the information from your proof sentence that it needs to run the proof, and it looks for your hash, the hash of your proof sentence in the file. It compares the balances from your proof sentence to the balances that are in the CSV that follow the hash in the CSV, and then it spits out a result. And the result, there's an example here, Merkle proof result, success. We found your proof sentence hash, and we're able to prove the integrity of the Merkle tree. That's all it is. That's the end user, retail trader participation in the TxQuick proof of liabilities. Anyone who wants to go deeper, the code's all on Git. There's all kinds of sort of superfluous output too in the verification result. You can find you've got the proof chain there gets displayed for the Merkle tree, and you got the Merkle root hash that you can compare and check out. But that's the gist of the user participation. We've made it as easy as we can for our users to participate, because we think that the participation is the key to the proof being valuable. So at the end of the day, what do you end up with? Proof of solvency. The reserves need to be greater than the liabilities. So you've proven your reserves, you've proven your liabilities via the Merkle tree proof, and you can as a user observe both of those externally now, and thus you know that your exchange, the exchange that you're using, the exchange that you're trusting with your funds, your money, is not a fractional reserve. So that's my presentation. A lot of credit to the Quadriga Initiative guys. Like I said, worked back and forth with them quite a bit. This project is free to use for anyone who wants to. There are some kind of gotchas in the license. So if you want to use it, I suggest reading the license. Gotchas are mostly around if you want to use it and you're a corporation, requiring that you be properly registered with all the regulatory bodies in whatever jurisdiction you're operating in. We've custom crafted this license to encourage participation, but participation by exchanges that are regulatory compliant. And then additional resources, the Digital Chamber of Commerce, they've got an amazing PDF. It's like a 30 to 40 page PDF, goes really in depth with all of the various aspects of proof of reserves. What I presented here is very, very brief in comparison, but highly recommend checking out. There's the PDF that's on this blog page here. And then of course the Quadriga Initiative, they have a complete framework for exchange transparency that they put a lot of thought into. And exchanges that participate in this exchange transparency framework are the sorts of exchanges that I think I would feel comfortable putting my funds in going forward in the future. That's it. Thank you. I really appreciate, again, the opportunity to present to you guys. It's great to be here.